Hello, geometry students. It is time to wake up the inner math giant that's inside of you. And we're going to do two examples of two-column proofs. And then, of course, I have something for you to do. Let's take a look at the first one here. So here we have our typical two-column proof problem. We have some given information and something we're supposed to prove. And here's the two columns ready for us to go. Remember, on the left go the statements, on the right go the reasons. And the idea is that we start with the givens and logically proceed to conclude what it is we are to prove. So let's take a look at the given information. Before we start the proof, we should kind of get an idea of where this is going. How are we going to prove these triangles are congruent? The first thing is that AB is parallel to ED. I'm going to mark that in the figure. Remember, we mark parallel lines with arrows. Okay. We're also told that AC is congruent to EC. That's already marked. And so let's see what else we know. We know that we have a pair of vertical angles here. So we have an angle, a side. It'd be nice if we had another side, another angle. We can't conclude that BC is congruent to DC because we weren't told C was the midpoint or anything like that. But what we can do is take advantage of the parallel lines. We have some alternate interior angles here. So angle A and angle E are alternate interior. So I'm not going to draw it in the diagram, but you should be able to see the Z. So angles that form a Z with parallel lines are alternate interior angles. And there we have it. We have angle, side, angle. So that's the way our proof is going to go. This is going to be an angle, side, angle proof. So let's start by listing the givens. We have AB is parallel to ED. And sometimes we can combine these givens. AC, it's kind of up to you. You can list them individually, or you can kind of combine them in one statement, put all the givens. We have AC is congruent to EC. All of that was given, so I kind of combined them. Makes it a little bit shorter. All right, so we've already taken care of these two congruent sides. Let's take care of these two vertical angles. So we have angle ACB is congruent to ECD. And that reason, vertical angles are congruent. Super. We got two of the things. So we've stated that these segments are congruent, angles are congruent. Now we need to state that angle A is congruent to angle E. So angle A is congruent to angle E. Why? Alternate interior. Look how much I'm going to abbreviate this. Alternate interior angles are congruent. Super. All right, we did it. We showed that they have matching triplets, a matching angle side angle triplet. So now we can conclude. We've shown enough to know that triangle ABC has got to be congruent to triangle EDC. Why? Well, we've said ASA, angle side angle. There we go. We've shown logically from given the given information, we've proceeded logically to show that these two triangles indeed have to be congruent. No other way about it. Okay, let's look at our second and final example. Here's another figure. And let's take a look at the given information. It says AB is congruent to DB. That wasn't marked, so I'm going to mark it. This side is congruent to that side. And again, we got to take a look now. Before we start writing statements and reasons, let's see where this is going. It's like creating an outline of the proof. How is this going to go? Well, we know that we have right angles here. These two right angles are congruent. But we know something else. Because these two sides are congruent, ABD is an isosceles triangle. That means the base angles are congruent. So that angle right there is congruent to this angle right here, because this side is the base. Now, if you look, we have angle, angle, side. That's all we need. So we're going to prove this using angle, angle, side. Okay, so let's start. Let's start with the givens. AB is congruent to DB. Why? Best reason in the world. They gave it to us. Okay, these two right angles are congruent, so we can say angle BCA is congruent to angle BCD. Why? Right angles congruent. Okay. Last thing, angle A is congruent to angle D. That's called the base angles theorem. So if you look on the reference sheet I gave you, the base angles of a isosceles triangle are congruent. So it's known as the base angles theorem. If you did something about base angles are congruent, then I kind of get what you mean. We did it. We established our three things. So time for the grand finale. All of triangle ABC is congruent to all of triangle DBC. So now we know that actually everything in these triangles has to be congruent. We know that AC is congruent to CD. We know these two angles here have to be congruent. Because by establishing those three things and using angle, angle, side, the whole triangle is congruent. So here we go. Angle, angle, side. Done. Okay, so finished. All right, before we go on to the journal assignment, I have something for you. So if you're doing this video on time, which means that you have it done before school starts on Wednesday, you can earn 5 extra credit points. Just send me an email at my usual email address and say, I can prove it. Okay, so those are the words that are going to get you extra credit. So just shoot me an email and say, I can prove it. Got some extra credit today for doing the video on time. Okay, here's your journal assignment. So this one, still, you don't have to do the whole proof by yourself. We're going to practice that in class, and that takes a little time to get used to. But this much should be no problem. I want you to copy the problem statement, so copy the given and the proof, and draw a little copy the diagram here. Make sure you get all the points labeled. Then copy the 2-column proof here, and then supply the reasons. So it's a circle here, so think, what does the circle tell us about these triangles and some of the segments? All right, give it your best shot. We'll check it in class. Good luck.